going to do our first lesson about understanding volume. This is lesson 11.6. So just like the other day, the investigate today, I don't have the materials that I need to do it at home, and I highly doubt that you do. Also, if you do happen to have anything like this, you can go ahead and do the investigate. But I'm going to talk you through what would be going on, what we would be doing in the classroom. So you can find the volume of a rectangular prism by counting unit cubes. So in yesterday's lesson, we had probably the easiest lesson that we've done all year. All we had to do was count how many cubes were in these solid figures that we were looking at. And I did mention that the purpose of that was so that we would be able to apply that to finding the volume of these figures. So that's what we're going to be doing today. So you can find the volume of a rectangular prism by counting the unit cubes. Now, what exactly is volume? Volume is the measure of the amount of space a solid figure occupies, and it's measured in cubic units. So off to the side, I just wrote, if you want to take a note somewhere, the volume is the amount of space that a figure occupies. And that would be like the formal definition, but another way of thinking of the volume that is helpful to students, it's not necessarily the most accurate definition, but thinking about how much you would be able, if the object was hollow, right? How much you would be able to fill the object up with. Because when you're dealing with things like cups and boxes, that's kind of what you're looking at, the space that the object has inside of it. So I'm not teaching that to you as the formal definition. This is the formal definition. However, it is kind of helpful to think of it that way. So for the investigate, each unit cube has a volume of 1 cube unit when you're doing this, okay? And we measure it in cubic units, and I'm going to explain why that is in a few minutes. For this investigate, if you happen to have unit cubes at home, you can do this with something. You can actually make your own net, or you can actually use a small box. You can do, I'm saying net, but I didn't explain to you what a net is. A net is basically a shape that's unfolded, and then you fold it back up into a shape. So what we're looking at here is a net, a rectangular prism net that was created into an actual box. So it was flat, and then we folded it up. And if we were in class, I have a whole bunch of these in the closet, but everything's still there, unfortunately, so I can't show you. But if you happen to have something like this, you can fill it up, and you can end up counting how many unit cubes can fit inside, and that's representing what the volume of that is. So if you have, I wouldn't suggest a huge box. Something else you could do that's not as quite as accurate, but if you have like Legos or blocks at home, or if you have a younger sibling that has little blocks or something, you can do the same type of a thing. You can get a box, an empty box, and you can see how many of the same size Legos or blocks fit inside. That's the key. The only thing is that they should be the same size. Now, technically, it won't be the same as this investigate, because this investigate is using unit cubes. So unless you have those at home, it won't be exactly the same. And that's okay. It's just kind of the idea of understanding what volume is. So you can try that if you'd like. And like I said yesterday, if you guys want to actually do it and you do it, please take pictures and send them, because I would love to see that. So anyway, back to it. I'm sorry that I can't do this with you guys, but let's look back up here. This rectangular prism is made up of, and they've already counted them for us. They broke it up into 2 8-unit cubes. So because we're saying if you can count the number of unit cubes, that's the volume, then when you count it, that's exactly the same. So the volume is 8. And that's it. So what we're going to be doing today is we're going to be looking at these figures okay, prisms, and we're going to be finding the volume of them. So I'm going to show you the easiest way to do it. But first we're going to look at the make connections here. To find the volume of three-dimensional figures, what we do is we measure in three directions. So before I told you I was going to explain why the units are cubed or cubic. And I'm going to tell you that cubic means that there's three of something going on, okay? And what we're measuring here is the length, the width, and the height. So that's 3 units, okay? So we're doing the length, width, and height. And if you if you recall when we do area, area is squared. The units are always squared, and that's because we're looking at 2 things, length and width, for example. So cubic is when you have 3 measurements. Okay, so volume is measured using cubic units, and it'll look like, sometimes it's written like this, cubic centimeters, and as you get older it will look like this, centimeters cubed with an exponent of 3, or inches cubed. In the textbook they're using the CU for cubic, so hopefully everyone will be used to that. So to answer this question, which has a greater volume, 1 cubic centimeter or 1 cubic inch, and then explain. Visually we can pretty much tell that it's the cubic inch. The reason why you do conversions before this is so that you can understand which unit is larger than the other. So if you weren't looking at a visual, you'd be able to say, okay, I know that inches are larger than centimeters, so 1 cubic inch is going to take up more space than a cubic centimeter, right? So 1 cubic inch has a greater volume . And you can say because it takes up more space, or because it's larger, anything like that. Because remember that the volume is a measure of the amount of space that a figure occupies. So this is occupying more space than this, right? Okay, so now let's figure out how we can find the volume. We're going to be looking at figures that have quite a few cubes in them. So can you simply count all of them? Yes, you can. You certainly can, but sometimes there's so many cubes that it's a little bit tough to just count them all, so I would like to try to help you guys figure out a little shorter way. So first they're saying they want us to find the volume of the prism if each cube represents a cubic centimeter, a cubic inch, and a cubic foot. Okay, so first let's think about this if it's centimeters. So we have 3 units going this way. We can consider this like the width maybe, 6 is probably the length, and then 2 is our height, right? So when we're finding the volume, we're considering all 3 of these. So you can sit here and count all of them if you want, or what I suggest is that you count how many there are in one section and then multiply it by however many sections are left. So let's take a look at this piece. There's 2 rows, and each row has 1, 2, 3, 4, 5, 6. So there's 6 in the top and 6 in the bottom, right? So that means that one of these is altogether 12. And then I have another row of 12 and another row of 12. So that's like 12 times 3, which is 36. I know that a lot of you are going to be tempted to do 12 plus 12 plus 12, but remember, we're at the end of 5th grade now. We want to be doing multiplication instead of repeated addition whenever we can. So the point here is to show you that regardless of whether this is measured in centimeters, inches, or feet, the volume is still 36 cubic units. So in this case, it's 36 cubic centimeters. If we said this was inches, it would be 36 cubic inches. And if we said it was feet, it would be 36 cubic feet. Okay? And that's that. Now, is it going to be, I'm not going to write this down, but we'll discuss it quickly. Will they actually be the same size if we built them with those different cubes? Of course not. They're not going to be the same size. Their volume, the number of the volume is the same because it's made up of the same number of cubes. But the size won't be the same because the size of the cubes is different, right? So if I made this up with 36 of these, it's going to be smaller than if I make it up with 36 of these. Okay, and that's the idea. So let's take a look at what you really need to know here, and that's how to figure out the volume, okay? And again, there's quite a few ways that you can do this. I really don't want anyone to just be sitting here and counting what they see, because if you just count what you see, you're not going to be able to count all of the cubes. So my suggestion is, like I said before, figure out how many are in one section and then use that to find the rest. So for example, number 1, if I can see that this has a length of 4 centimeters, width of 4 centimeters, and a height of 3 centimeters. So I'm just going to start labeling that because we are going to eventually need to know that in the lessons coming up. Okay. Now, each cube is 1 cubic centimeter in this case. So what I'm going to do is I'm going to look at this first section here. I'm going to count how many cubes are here, and then I'm going to use that to figure out the total. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 again. And then I'm going to look at the sides and see how many rows I have of 12. So I've got this one is another 12 here. Here's another 12, and here's another 12. So that's 4 12s. So what I'm going to do is I'm going to make my life easier and do 12 times 4, which is 48. So my volume is 48 cubic centimeters. And that's it. Okay. Number 2, my length here is 3 inches, width is 2 inches, and the height is 4 inches. So I'm going to look at one section here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again with the 12. So I have 12 here, and then I have a second row of 12. So that's 12 times 2, which is 24. So my volume is 24 cubic inches. Okay. I'm going to skip over 3 and 4 for a second because I'm going to have you guys do that yourself. I'm going to show you how we compare. Sometimes you have to be careful with these comparing volumes. Don't jump to conclusions just because one of them, one of them looks like it's going to be bigger. It might not actually be bigger. So you might be looking at this first one and saying, look how much longer it is than that. It's going to be larger. Let's actually see. So the second half of what you're going to do in this lesson is compare the volumes of 2 figures. Okay, so for this first one, I've got, now I'm going to do it this way this time because it's going to be easier to multiply. So I'm going to look at this piece here, and I know I have 4 here. Okay, and now let's see how many rows of 4 I have. 1, 2, 3, 4, 5, 6, 7, 8. So 4 times 8 is 32. Now, if you didn't see it that way, you could have done the first section here, and you would count 16 times 2, which is 32. Okay, so the first volume is 32 cubic inches. Okay, now let's compare it to this one. So let's look at the first section here. 1, 2, 4, 6, 8. Okay, I've got 8. Wow, something besides 12, guys. And now let's see how many rows of 8 I have. 1, 2, 3, 4. So 8 times 4 is, holy Hannah, 32. Turns out these actually have the exact same volume. And look at how different they look. It's interesting, right? So sometimes you can have shapes that have the same volume. They actually technically take up the same amount of space, but the space that they're taking up might be in different directions. So that's a perfect example for number 5. So this is it. What I'd like for you guys to do is please pause, and I want you to try 3, 4, and 6. Okay, I seem to have cut off this part here, so let's add it in here. Blank cubic feet is blank cubic feet. So you write the volume of this one here, the volume of this one here, and then compare. Okay? All right, let's try it. Okay, so number 3 should have gotten 36 cubic feet. If you look at the front face, there's 18 there and 2 rows, so that would be 18 times 2. Or you can also go the other way. You can say that there's 6 here, and then you would notice that there are 6 rows, and multiply 6 by 6. Number 4, the front is 15, and there's 4 rows. Going this way, there's 3, 6, 9, 12. You could do 12 and 5 rows, and you'll get the same answer. For number 6, you find that the first one has 108 cubic feet. So I chose to do the side, which was 12, and then I saw that there was 9 rows. So 12 times 9 is 108. And over here I did the side again, which was 10, and there was 8 rows of 10. So that gave me 80. So 108 cubic feet is greater than 80 cubic feet. Okay guys, so again, make sure you try to use my strategies like I'm doing here, counting one row and then multiplying, because you really don't want to sit here and count everything. And if you're just counting what you see, you're not going to count all of the cubes that are in there, okay? So make sure you use one of these strategies that I've showed you. Okay, have fun finding your volume.